Hello viewers, today we are going to look at our second method that we use in linear programming, and that is the Simplex Tableau Method. In other words, we are going to look at the second alternative that we use whenever we are working on the linear programming scenarios or problems. So, Simplex Tableau Method, this is an alternative to the graphical method, and it's used for two or more unknowns. Simplex method involves the introduction of slack variables to change inequalities into equations. So, when the examiner brings a number which has two unknowns, remember we said if the examiner has given a question where we have one limiting factor, we said there we use the decision making under the limiting factor. But if you see that you have two unknowns, in other words, when you have more than one limiting factor, we said we use linear programming. But still, when you have these two unknowns within, or when you have two limiting factors, but within the limiting factors, we have two unknowns that we are going to compute. What we do, you find that most of the times the examiner will specify whether you are going to be using graphical or the simplex method, because the two methods are applicable for the two unknowns. But when the examiner brings more than two unknowns, maybe there are three, there are four, then there, even if he doesn't tell you, or even if he doesn't specify that you are going to be using simplex method, you just know it that you're supposed to use the simplex method, because the examiner will know that this problem, or this linear programming problem that we have brought, there is no way you cannot use the geographical method to solve it, because of the unknowns being maybe more than three. So long as they are starting from three, then we can only apply the linear programming, because we said that the geographical method is only working for only two unknowns. And those unknowns, it's working on those two because we are seeing that on a graph, we always have the y-axis and the x-axis. If the examiner brings three unknowns, there is no way you are going to plot three coordinates on a graph. That's why we limit that one to only the two unknowns. But for this, the simplex method, for it works on all the unknowns, whether they are two, because they can be two and the examiner specifies that I want you to use simplex method. So it's not a must that whenever we see the simplex method, it's not that you have three unknowns, no. But when the examiner brings two unknowns, then he's supposed to tell you which, because both methods can apply to the two unknowns. So the simplex method, we say it is the one that is going to introduce in a new component that you haven't seen, the one we call the stack variables. And the role for those stack variables, or the introduction of those stack variables, they are to make sure that you can be able to change the inequality into the equations. Because we saw from our geographical method that, from our graphical method that if you have to change the code, because there is no way you can get the coordinates that you could plot on a graph if at all you have not converted the inequalities into equations. That's what we saw. Because there it has been very easy for us to get to that point. And we can be able to solve those when you are picking some variables. But here, the unknowns are going to be 3. So the only way to remove the inequality or the inequality sign, either greater than or equal to, or it is less than or equal to, the only way we are going to remove that is by introducing what we call the slack variables. So we introduce the slack variables, but those slack variables, they are going to be representing unutilized capacity of the resources. In other words, there are some resources that you are not going to fully utilize. So that portion that is not utilized is what we are providing as the slack variables. So that's basically what we can talk about as far as the theoretical aspect on the simplex method is concerned. Because the other aspect that we can talk about are the steps that we are supposed to follow when we are using the simplex tableau method. In other words, when we are computing any linear programming model, we need to make sure that we are going to follow these steps so long as we are using the simplex method. So let's go through these different steps. Then we can, after analyzing them, we can now have something that will have something that will help us to understand these procedures. Because when you have understood the steps, then we can be able to have a practical question, and we see how we can be able to apply all those steps, and we see how they are going to be flowing. So let's dive into the steps that will follow under the simplex tableau method. One, we have to formulate the problem into a linear programming model. In other words, we have to generate the objective function and the constraints. Because we said a linear programming model in our first videos on linear programming, we said a linear programming model comprises of the objective function, or what the organization is intending to achieve. Secondly, it has the constraints, the limited resource that is limiting us not to achieve the desired objective. So when we formulate, we said the combination of those two forms what we call the linear programming model. So we formulate that. If at all it has been given in the question, you don't need to formulate it again. You just go by what they have given. Because some questions you may find that they have given you the linear programming model. And maybe because what happens if by any chance they give you the linear programming model, it means when you look at the question, they will ask you to compute the shadow price or the opportunity cost, because they would have reduced the time that you would have taken for you when you are formulating this model. So if you see that some of the steps have been eliminated, just there's some extra task that has been added on that. Because at the end of the day, it will be very hard for a student if at all they give you to formulate a linear programming model, and at the same time they tell you to calculate the shadow price. I'm not saying they can't tell you to do that, but that would be a very long question. In other words, the question will take a lot of time. And we know that most of the times, time that is affecting us, not because we don't know the concepts. Just analyzing these concepts and maybe the time management, those are very, very, very important, because time is never on our side. So the second is we introducing the Slack variables. The reason as why we are going to be introducing in these Slack variables is to change the inequalities into equations. That's what we talked about. That the only reason as why we are getting involved with these Slack variables is because we want to introduce in the equations to remove the inequalities. And we said the Slack variables, those are unutilized components within a given resource or within the available resource. So that is the second step. The third step is to formulate the initial simplex tableau. In other words, we formulate the first table. That first table, we always get that information from our linear programming model. We get the information and we put all that information into that first table. It is that first table which doesn't involve computations. We just pick the figures just like the way they have been arranged in a given model, linear programming model, and we just insert them in our tables. We shall see how we do that when we start the practical computations. So when that third step is done, the next thing to do is to determine the pivot column, pivot row, and the pivot number. This is where now the gist starts, or what makes the simplex tableau method a bit tricky or a bit confusing, because it's from this point that we get to do some computations. So these computations that we are going to be doing, they are going to help us get the pivot column, the pivot row, and the pivot number. So someone may want to know what is a pivot column, what is a pivot row, what is a pivot number. And we always look at it in that same way, that you first get the pivot column before you get the pivot row. And there is no way you can get the pivot number if you don't have a pivot column and a pivot row. So what are they mean? A pivot column is a column with the highest value of the objective function. We say the objective function, we have already formulated it because it's the one we start to formulate, which shows the overall objective of the model, whether it is going to be maximizing profit, minimizing costs, whatever has been given, it's what we start with. So we pick the value, the highest value of that model. Whether it has been contribution, just like in the other example we did, we had a contribution and we also had contribution of 16 and contribution of 14. So we shall go with the contribution of 16. So for those who haven't seen the other number that we did under the geographical method, you can also go through that, because we are going to have similar things that we are going to be talking about, because some of these, the objective function, we looked at those things when we analyzed the graphical approach and when we also went through our first introduction to linear programming. So that's it, the highest value of the objective function. Where that value is, it's what we call the pivot column. In other words, a pivot column, it's something that is pivoted, it's something that has been fixed somewhere, where these other things, they may start to change from. But for this, as far as simplex is concerned, we just pick the value with the highest we just pick the column with the highest value of the objective function. That column is going to be our pivot column. The second, which is the pivot row, a pivot row is a row with the lowest value after dividing the solution quantitative values with the corresponding value in the pivot column. In other words, we get the solution quantitative values. This solution quantitative value is one of the items that are going to be there in our pivot table. So we get the values that are going to be in the solution quantitative values. We divide those by the number within the pivot column. We divide each with its corresponding value in the pivot column. After dividing, we pick the one which has given us the lowest result. In other words, after dividing, you get that value that is smallest from those solution quantitative values. So that value that is going to be the smallest of the smallest result that we've got after dividing the solution quantity by their corresponding pivot column figures. That smallest value is that where that smallest value is, where it belongs, it becomes our pivot row. In other words, a row, we know that a row is always going horizontally. All the figures that are within that row, they are what we call the pivot row. The last one is the pivot number. A pivot number is that number where the pivot column meets the pivot row, or it is where the pivot row meets the pivot column. In other words, where those two meet. Because the pivot column is moving vertically, then the pivot row is moving horizontally. So there is, at some point they are going to meet, but at that point where they meet is what the number that within that point where they have met is what we call the pivot number. So now listen to what happens after we have identified those two. Because when you have identified those two, then we can have some of these other things following. But it is those first numbers that are very important as far as the computations are concerned. That was our fourth step. Then our fifth step, we replace the slack in the pivot row with the unknown in the pivot column, and we divide all values in the pivot row by the pivot number. In other words, what that means is that we get, after identifying the pivot number, we make sure that all the values that are within the pivot row we are going to replace with the number within the pivot column. In other words, it's like we are replacing the slacks, because these slacks are going to be in a given column. But these slacks, we are going to replace them by the number in the pivot row where that unknown, it's like we are just looking at their correspondence values between the pivot row and the pivot column. But at the end of the day, we first get the pivot the pivot row figures, we divide them by the pivot number. And what comes out is that we want to make, the reason as why we are doing that is because we want to make we want to make all values in the pivot column 0, apart from the pivot number. In other words, we want to make all the values that are going to be within the pivot column zeros. And we just leave only the pivot number, which has not been changed. And the reason as why we are doing that is that we want to do some elimination. We eliminate some of the figures. That's why we are making them 0. And the only way we can do that, we use the row operations. Row operations, it's what we are going to look at when we go to the computation, because it will be, again, very hard to illustrate if at all we are not doing the practical simulation. So just know we are going to be using the row operation. I'll try to explain more when we are doing the practical simulation. Then the last step is we repeat step 4 and step 6 until all values in the objective function, in other words, all the values in the objective function row are either negative or 0. In other words, because we said that these figures, when we make them 0, or we make them to look to be negative, it means we have done it. Because at the end of the day, we don't have, remember the other non-negativity. When we get all of those figures negative, then we can stop there. But if you find that there are some positive values that are within the objective function, then you have to repeat those steps, step 4 and step 6. So that's what we wanted to do. That's all that we wanted to look at as far as the steps are concerned. But there is also a small matter of the sensitivity analysis. Sensitivity analysis is more common in strategy, business strategy. But here what we are trying to look at is just a small aspect. And we want to look at a scenario where we are going to be having the shadow price. And that shadow price, the other time we've been computing the shadow price when we are just using only one variable. But here we want to look at if at all there's going to be a range within the resources. Maybe they are saying that what if we increase the limited resource from 0 to 5? What will happen? When they have not specified the exact number that is going to change, but it is going to be in a range, what are we going to be doing? So that's what we are going to be doing under the sensitivity analysis. The other one, it is the same thing. We are also going to be just like looking for the shadow price, but here we are looking for it in terms of a range, of a given range. And that's what we are going to do. We have, those are the simulations that we have. We have interpretation of the simplex final table, and that is from March 2022, question 5, part A. We have also the one we are going to be solving. That is, we are getting that question from December 2016, question 4. But my approach, we are going to first of all look at how to solve using the simplex method before we interpret, because we are only interpreting something at least we have understood. So the approach is, we have to first of all look at the how we can be able to compute using the simplex method. Then we know how to interpret the final simplex table. Because we said that some of these questions from the linear programming, the examiner may just give you the final table for you to just interpret and make a decision. Or the examiner may tell you to just compute, and so that you get the final table by yourself and make an advice. So whichever way that the examiner may want to set that is what we are targeting, because we shall first of all look at how to calculate it, how to be able to compute, and you get the final simplex tableau before we start to interpret. So we have some trial numbers: December 2021, question 4A, November 2018, question 4, November 2017, question 5, October 2021, question 5A. We have May 2018, question 5, December 2022, question. That question is not, it's around about question 5, around, I think question 5 or question 3. Then November 2019, question 5A, and December 2016, question 4A and B. This is what we are going to look at. So that's all that I wanted us to talk about as far as the introduction to simplex is concerned. Let's meet in the next video. For those who haven't subscribed, please do, because that will not only help the channel to grow, but it will also help you to get to know when at least you can be able to have a range of the videos that you can watch and be able to improve on your understanding. Thank you for watching.